All right, so yeah, in this talk, I promised to tell you more about Scientific Python and specifically the Scientific Python project that we've been running for the past few years. I'm very excited to do so, but I thought since this is a little bit more informal, that I might use this opportunity to give you a bit of a behind the scene look and a personal overview of how this project came to be. And I wanted to tell you a bit more about the major role that Berkeley has played in this space, Berkeley and BITS has played in this space, and the very long history that we have with Scientific Python. Now, disclaimer, my memory is obviously incomplete and subjective, but I think I've managed to capture the general gist. This is fairly informal, so feel free to post questions on the chat, and Jarrod will relay those to me. Get my slides moving here. All right, so let us travel back to around 2000 to 2004.
Slides seem stuck.
What's that?
Were you supposed to? Yeah, there we go.
Okay. Yeah, so let's go back to around 2000, 2004. So at this point in time, Fernando Pérez is a grad student in physics at CU Boulder, and he's working on wavelet analysis using Mathematica. And he became interested in a new language called Python, which at the time lacked symbolic and numerical computation facilities. Jarrod Millman worked at the Brain Imaging Center, and there he was supporting the analysis pipeline, which was this crazy mixture of MATLAB, IDL, Awk, Bash, C, bunch of other things. And I was at the time a grad student in applied mathematics in South Africa, and I was frustrated by the lack of a workable MATLAB installation for my Linux machine, and was experiencing a lot of issues with the license servers. I just couldn't use the software when I needed to. So I switched to using GNU Octave, and I was actively helping the project to develop at the time. So because of this pipeline challenge, Jarrod became motivated to replace their imaging analysis pipeline with Python. Keith Worsley, who was a big figure in neuroscience, introduced Jarrod to Jonathan Taylor, who was a young upcoming statistician and is now a professor at Stanford. Just Googling Python imaging neuroscience, Jarrod came across John Hunter, who was doing ECOG at the Children's Hospital in Chicago. And they had a MATLAB pipeline that he wanted to replace in Python as well. So for that purpose, John started a project called Matplotlib. And John introduced Jarrod to Fernando. So at that point, there were two array libraries for Python. So the first was numeric, and that was more geared towards handling smaller data arrays. And then NumArray was written by the astronomers to handle the larger imaging sets. But this schism, this split in the community was truly problematic and made it very difficult for newcomers to onboard into the ecosystem. So Jarrod and Matthew Brett, who was visiting, he was a visiting researcher at the time, they organized a few meetings. And these meetings brought Travis Oliphant, who was the numeric maintainer, and Perry Greenfield, the NumArray maintainer, together. And during these meetings, they figured out a way to meld these two projects into one. And that is the project that eventually ended up becoming NumPy. So around 2005, the first course in scientific computing in Python was given. It was probably one of the earliest courses anywhere on this topic. It was in Tolman Hall, where the new data science building is going to be, and that was given by Fernando and John. Some of you may know Dav Clark. He later became a BITS fellow. He was also at that meeting, came up from Stanford. My advisor, Ben Harpst, he regularly visited Colorado on a sabbatical. And this one year he came back and he was incredibly excited. He was inspired by this student over there, by postdoc over there, Fernando. And he was very excited about the prospects of this new language, Python. So I dropped my work on Octave, switched to Python. But he really wanted me and Fernando to meet. So soon after, in 2006, Fernando traveled to South Africa, and he taught what we called the Pi for Science workshop. and I stepped in to help him. So that's where we met for the first time. Then around 2007, Joe Harrington, who worked in planetary science, wanted to teach a course in using NumPy and SciPy and these tools. And because the tools were so poorly documented, he found it hard to use for his course. So he had a little bit of money and he wanted to pay to change, to improve the documentation situation. So Fernando and Jarrod phoned me up, and with support from my advisor, I ran the documentation marathon, which in the end, I ran it for 2 years. There was another year after that. So together with the community, we built a Wikipedia-like system. And over 2 years, we took NumPy and SciPy from having virtually no documentation to being fully documented, which greatly increased the accessibility of the libraries. So in 2008, Fernando was appointed at the Brain Imaging Center, and there he worked closely with Jarrod. Around 2010, Jarrod co-organized SciPy India, and there we started working together on the proceeding system for the US SciPy conference. Around this time, Josh Bloom, a professor in astronomy, was teaching an annual Python bootcamp and the AY250 astronomy course. And through that, he really helped to establish Python both in the astronomy community and on Berkeley campus. So now we fast forward to 2015. BIDS is formed, and I joined as one of the first computational fellows, it was called at the time. And around then, the data science curriculum was launched on campus, and it was built around Python as well. Around 2017, we started working on the first ever grants for NumPy. These were given to us by the Moore and the Sloan Foundations. And as part of that work, we brought key ecosystem developers to campus. And one of the challenges that the group discussed was that as the projects got big, developers could no longer coordinate their work in the way they were used to. So in the early days of SciPy and NumPy, we would meet, 20, 30, 40, 50, eventually 80 people would meet, and they could still fit in one room or around a table and discuss the future of this ecosystem, where to position it strategically, how to align their efforts. But around 2017, the SciPy conference was already 1,000 people in attendance, and it was just no longer feasible to communicate that way. So, we had this ecosystem that without much guidance grew very organically, and many projects in the process became quite siloed, doing their own little thing. There was very little unity. There was very little to no careful cross-project design and coordination. And while tools were sometimes brought or borrowed from one project and used in another, the tools were then developed independently and would often take on a life of their own. But because of the success of the projects, because of the adoption, also as part of the data science movement, there were now very many more users to support, but there was the number of developers didn't increase that much, and there was no framework within which to support all these new users. Industry at the same time became, probably because of machine learning, became much more interested in the ecosystem, and we were worried, what did this mean for the developers? How would the community remain involved in steering and designing the projects that they founded? So we started thinking about ways to bring the community together again. And we discussed, we wanted to bring them together so they could discuss strategy, so they could improve the uniformity for the benefit of the users. If you look like something at product like MATLAB, they have a product team, they have a documentation team, they work closely together, very unified experience for the users. And we wanted to give our users the same. We wanted to share technical infrastructure and tools so that we didn't keep reinventing the wheels, so that we didn't keep on wasting time. And we wanted to make sure that projects were well governed, were community governed, and were owned by the community of researcher developers. So here's the last bit of timeline I want to discuss. So around 2018, that was the time of that NumPy meeting. We We created the first scientific Python site. It was just a scaffolding for that site, more or less. But this is where we started really writing up the question about how to communicate how to coordinate the community. Around December of 2018, we had a conversation with Chris Menzel, who was then at the Moore Foundation, and he asked us to write a short proposal about this work that we envisioned. So in January of 2019, we produced the first draft of that, and eventually in June 2020, that funding was approved. And through that, Jarrod and I were able to, in December of 2020, officially start the Scientific Python project. Okay, so that gives you the personal history of how we came to this point. And now I'd like to tell you just a little bit more about Scientific Python project, the Scientific Python project, what it is and how it works, and everything we've done since 2020. Right, so Scientific Python is a project which is aimed at better coordinating the ecosystem and to support specifically the maintainers of that ecosystem. Here, if you want to learn more about the project after the talk, you should take a look at our website, scientific-python.org. There's a lot of information there. One of the things you'll see on the website is that we have sort of these 6 key areas of focus.
Your slide seems stuck.
What's that?
Your slide seems stuck.
Thank you. There's one area missing here, which is tools, but I'll get to that in the end. So yeah, we've got spec summits, a development guide, lecture notes. We're working on sparse arrays, and we have community coordination. So I'll go into each of those a little bit, just tell you what we're doing there. Right, so the specs are Scientific Python ecosystem coordination documents. So if you followed along with Python development or with NumPy development, Python has these documents that discuss technical proposals about changes they want to make to the library. And then there's discussion around these proposals and a process whereby these proposals are vetted and approved by the community. Jarrod took that process and modified it for NumPy. So NumPy is a similar process, and we have the same for Scientific Python now. The difference between the specs and something like Python's PEPs or NumPy's NEPs is that those are technical documents very specifically geared towards one project, whereas what we're talking about here, we're really looking at cross-cutting concerns across various projects in the community. So we're taking a much broader view. The specs are also not that technical in nature. They often refer to external sources for the technical details, but it tries to be an index of development ideas where projects can come, especially new projects can come and see how are things done in the ecosystem. It's also a mechanism whereby smaller projects can have a voice in the ecosystem, because usually they would not be heard very easily. But if they write up a spec, if it's a good idea, if the bigger projects like it, then those ideas can be adopted. So the adoption works by having the big projects, what we call the core projects, evaluate these proposals and endorse them. So basically say, do we think this is a good idea? It doesn't even necessarily mean that they're implementing it themselves. It just means that they say, yeah, if you want to go this route, it's probably smart. The specs are very much, there's no control over the ecosystem. Libraries can do exactly what they want to, but we have these guidelines to make it easier for developers to get going. I mean, one of the big things we're trying to address with Scientific Python is to reduce the overload on maintainers, to reduce the amount of chores they have to do just to get their projects out there. We really want to free them up to think about their domain problem or their domain library. So we're trying to take care of sort of the busy work and the all these things they would have to think about otherwise. We're just trying to get that in the central location, make it easier to access. The spec process is driven by the spec steering committee. These are community volunteers who come in and help us facilitate the process of shepherding these docs through the process of being proposed, accepted, evaluated, and written, and so forth. Show you a few example specs so you get a feeling of, I think I had a list earlier on. see. Yeah, so here's the full list of specs we have so far. You can see it covers everything from dependencies to API dispatching to how do you keep your password safe in the project? How do you seed random numbers? It's really all the cross-cutting concerns that we think about. So here's an example. So the first spec we wrote was which versions do the developers have to support? So again, like I mentioned, we're trying to reduce the maintenance burden on developers, and the developers feel a great responsibility to make life easier for their users. So they would typically try to support as many versions of Python as they can. They will try and support as many versions of SciPy and NumPy as they can so that you can install it easily on your system. But ultimately, supporting many versions of those libraries and the language comes at it comes at a cost. So we have this policy that basically says, or this recommendation that basically says, look, if you at least support these 3 versions, or if you support Python over this period of time, then that's good enough for the ecosystem, and it frees you up to pay attention to other things. Another example is spec 1, which is about lazy loading. So in the early days of SciPy, Python has this concept of namespaces, and the namespaces basically extend to sub-namespaces. And as you have these deep hierarchies of functions, it can become quite hard to discover them. So if you're working inside of something like IPython or Jupyter, you have this handy tab completion, but you can only tab complete once you've imported all the modules as deep in the tree as you needed to go. We didn't like that situation, but originally it was costly from an import perspective to just import the whole tree. So Python eventually came up with a new feature that allowed us to handle that much more smartly and efficiently. And as project, we're trying to figure out how do we use this new feature. We figure it out once, we write it up. There's the spec. And we wrote a little library to expose that functionality, and now all the libraries can come together and use that same functionality together. If you introduce a problem, at least you introduce it in one place. You can fix it in one place, and the maintainers don't have to worry about it. Spec 4 is another coordinating mechanism for deploying wheels regularly. So wheels are the binary artifacts. Every night, projects in their continuous integration in their testing systems, they build a version of the project. But it would be really handy if this test version so you have this mechanism whereby projects, every night they produce a development version of the project. And before, the projects would just do it individually, and then no one would know where to find those artifacts. So spec 4 is all about saying, let's upload this to a single central repository. Here's how you do it. Here's how you keep it safe and secure. Here's how other projects can use it in their testing frameworks. And that way we much better coordinate the testing. We catch errors earlier, win-win. Right, moving on from the specs to the second category here, we have the developer summits. So the summits are they're in-person working meetings, and they're all about working. So the goal there is to bring key people in the ecosystem together, key volunteers in the ecosystem. We spend a lot of time beforehand to plan work that we're going to do. Here's yesterday's meeting for this upcoming summit that's happening in Seattle in June. So we coordinate the work we're going to do. We identify pressing matters in the ecosystem that need to be addressed. And then we all get together in one space, and just for a week, or in this case for 3 days, we just work on knocking those out. And we've had some really good successes on this. I think one of the key examples for me was we really wanted to improve the situation around sparse, and I'll get to that later on, but this in-person workshop really was key to bringing all the different people together in one room. Because you land in this situation where you have a core developer on SciPy that's responsible for approving the changes that you make. So even if you work at the summit, you get a lot of work done, you still have this one person that needs to review your work and get it into the library. But if you can get that person into the room with you, then changes can happen much more quickly. Okay, next we have the development guide. So again, if you're starting out with a new library, then how do you know which best practices to follow? How do you know what changed over the past year? You're busy trying to figure out how to implement the routines in your library. So as you're staying up to date with that, you don't really have time to read up on what changed the ecosystem, how did setup tools break various libraries, what new changes are on GitHub CI. So all these things the community can track for you and aggregate in these documentation pages. So you at least have one central resource to refer to. One example of a tool that was developed as part of that development guide by Henry Schreiner is this repo review. So this is a WebAssembly tool that will run in your browser, connect to your project repository, and do a bunch of checks. Just make sure that you have a license, you have tests, you use a linter correctly, et cetera, making it much easier to just have a checklist for is my project basically up to scratch and up to standard. The SciPy lecture notes. So this is where we basically go beyond where the carpentries go, and we say, we'd like to teach you about how to use these tools, but we'd like to go, it's fine to start with the basics, but we really want to take you to the point where you can use this for your science and your research. So it goes fairly in depth. And yeah, it was developed by numerous members of the community, as you can see there on the cover. So these notes were fairly well established, but then they languished for a while. So Scientific Python took over the maintenance of these notes, and we've been refurbishing them both at the summits and whenever we get a chance, update them, to use the latest libraries, to use the newest changes in NumPy API, and so forth. So you can see they start off with Python. They talk about Python and NumPy, Matplotlib, the basics, and then they go all the way through to more advanced topics like optimization, image processing, using sparse matrices, and so forth. Then, as I mentioned, one of our big focuses is improving sparse array support. So especially as we move into much larger data sets, it's important to be able to handle sparse matrices. You can have enormous matrices, but they only have entries in a few locations. And you should be able to store those and operate on those efficiently. We have fairly reasonable machinery for doing that in SciPy, but unfortunately, this was written a long time ago when the predominant API wasn't the NumPy array that we know now, but there was also in NumPy a concept known as, they were known as matrices before we used arrays. And matrices and arrays are fundamentally, they operate quite differently. Matrices are basically 2D, arrays are ND, and their interfaces look different. So our goal with this project was to take the SciPy array functionality and to port it to the NumPy array API to make it much more modern and to support the various dimensionalities as well. So starting with 1D support, eventually we may end up with ND support, but at least going 1D, 2D, and not only 2D. So the sparse functionality becomes much more compatible with the majority of research codes. All right, I think I spoke about that. Right, and then finally, we try and provide platforms where the community can connect and communicate with one another. So we have a discourse server where we have discussions, and SciPy recently moved their list over there. Scikit-Image has been using it for a long time. That's where the spec coordination happens. And then for more informal, lighter weight conversation, we have a Discord. So it's just a chat server that also supports video and good for quick to and fro conversations. Then we also have the blog. So we've aggregated some of the community blogs that were out there already, like the Matplotlib blog, and we put a procedure in place to make it easy for the community to contribute blog posts and write in a more informal way about the work they're doing and yeah, the projects they're involved with. I mentioned that the one thing that was missing from that front page was the tools work that we're doing. So as I mentioned earlier on, we try and do a lot of work to support the maintainers so that they don't have to carry such a big burden. And part of that is centralizing the maintenance of common tools used across the ecosystem. So, I remember from Scikit-Image, for example, one of the early things we wanted to do is generate API documentation. Now, to generate API documentation, you need to go through the functions, find their signatures, list them all in a coherent way, in a way that your documentation compilation engine can understand. So, we grabbed a tool that Fernando had written for IPython back in the day. That tool got developed in Scikit-Image and several other places, got specialized. Those are the types of tools that we really want to host centrally so that we can maintain it on behalf of the whole ecosystem. So we've got tools for the web. This is mainly a theme. Let me scroll here. So yeah, for the web, we mainly have the Scientific Python Hugo theme. That's like a Hugo theme that's roughly equivalent to the PyData Sphinx theme, which is commonly used for documentation in the ecosystem. For documentation, for development, I'll just highlight a few. We've got Spin, which is essentially the user-friendly interface to building NumPy, Scikit-Image, and so forth. It hides all the complexity of building with Meson, and you get a user-friendly interface that you can invoke. Repo review, I already showed you. Change list is the thing we use to automatically generate release notes for each release. We've got a community calendar that we host. So you submit a pull request, change a YAML file on our website, and it renders a calendar that you can subscribe to in Google. We've got a developer dashboard. So it looks at your repository and it calculate some statistics on how many PRs were open and closed, how healthy is your project, where are pain points that you might need to pay attention to, and so forth. So an analytics dashboard for your project. We also have analytics like Google Analytics style that we host for various projects. I think I'll stop there for now. All right, so what is on the horizon? I want to highlight here a section from Fernando, who's our new academic director. I want to highlight a piece from his vision that he put down for bids. I'm very excited to see this renewed emphasis on the importance of open software and research. He wrote, our scientists partner with an extended distributed community of other researchers and developers to build an ecosystem that benefits all. This is how we will build much more in coming years, working grounded in the expertise of our scholars and immediately applied to research and educational needs, but in open collaboration with partners near and far to build access to research and education that is impactful, accessible, and fair. So yeah, for me, these values align so perfectly with the work that we've been doing over the past decade and a half and what we want to see on Berkeley campus. So some exciting prospects I wanted to highlight. There's an open source projects office being established at Berkeley, and I think it's great to have a central hub for conversation around open source. If you want to learn more about that, you can chat to Jarrod Millman, who's also on this call. Areas that we intend to work on as part of Scientific Python. We really want to improve the statistics offering in Python, which I think has a few blind spots. Currently, the offering is very econometric centered, which is fine, but it doesn't suit all our users. We want to focus on specific subdomains that use our tools. For example, improve the offering for astronomy or for earth and space science. There are a few other domains, maybe geosciences, where we really want to go in and make sure that the tools are well compatible with the needs of those sub-communities. There's a panel this Friday on a very important topic that has just become even more relevant: supply chain security, with a recent XZ project infiltration situation that took place. We're of course now very aware of the risks that we face in shipping this software to millions of computers.
Stéfan, Thursday, not Friday. It's Thursday.
Say again?
Thursday, not Friday.
Thursday. Apologies. Is the date right? Is it May 9th?
Yes, Thursday, 4 to 6.
Okay, perfect. Then we also better want to coordinate releases. We want to make sure that this is an idea that's come along, that's been there for a long time, but no one's been able to act on it. But you should be able to essentially install a combination of a set of ecosystem libraries, maybe the most commonly used libraries, and have some guarantee that these libraries have been tested together, will work well together. Similar to the notion of Ubuntu releasing every quarter or whenever they do, really making sure that we can provide a stable set of cross-tested packages. We're going to host some summer schools where both for developers and for users of the ecosystem. And then finally, we also want to look at shared governance models and make sure that all the projects in the ecosystem have solid governance models that are essentially compatible or have been vetted by the community in the same way. All right, so I think we can switch modes to the Q&A. Again, if you want to learn more about the project, please navigate to scientific-python.org, and please connect with me on Mastodon. That's where I hang out nowadays. Yeah, so I'll open the floor to questions.
Stéfan, maybe one question to prompt discussion, and thanks for that wonderful overview. What do you see as immediate opportunities and ways in which BIDS and your team, in the context of kind of this new direction that we're trying to build upon, can help the campus community? And I know we have some guests from beyond campus, and that a lot of this is framed as us being part of this distributed community, but we are first and foremost a campus entity. And so, what do you see as key opportunities at various levels where you imagine we could serve the needs? And if folks on the call have questions or ideas, we welcome your input. This is very much a conversation. We really want to build a sense of a thriving and useful community on campus regarding these things.
Yeah, thanks for that, Fernando. Yeah, I think we've spoken a lot about coordination between the projects and between campus and the community out there. But you're absolutely right that first and foremost we need to address the needs of the researchers on campus. And there's a lot of Python usage on campus. There's there are a lot of good things happening and a lot of talent on campus that can be harnessed. And I think, we haven't really had BIDS has started to be that central meeting place where, especially when we had the physical place, it was going to be easy for that to happen. People would flow through a single place where they could talk, where they could ask questions about the ecosystem or tell us about their research problems. We could really work out what is the best way to support them. But I think we still have quite a ways to go in making sure that the needs of the campus community are better addressed, the tools needs, and also that we involve the campus community more closely in the development of these tools. Because I think when you own a tool, when you modify a tool for your own purposes, it does two things for you. First, it makes you understand the problem that you're dealing with really well. And then once you understand the problem really well, you build a tool that is perfectly suited for your problem. And so it's a valuable process to be involved in the development of your own tool. And I'd love to see more of that happening on campus.
Stéfan, I have to go.
Yep.
Yeah, so another way that we'd love to interact with people is, so most of our work is at this point is grant funded, and so that's somewhat focused our work on things. But we also have, a long track record that's been established as scientific Python experts. We also have some funding track record, and we would love to collaborate in some kind of capacity with researchers submitting new grants. I think one of the things we have is that many of the open source calls that are coming out now ask for plans for governance and how you relate back to the major community and how you're going to do a sustainability model. I think that's something that we can partner with other researchers on campus and help address that question. And as we're building up a team, we're hoping, I think, to provide a central pool of expertise and resources that can help domain experts and researchers that are building out these capacities. And with Scientific Python, we certainly have that covered. I think we're also hoping with the OSPO to be much more language agnostic. So that's definitely a way we're very excited to collaborate and grow together as a community.
Stéfan, I don't know if you're watching the chat. You have a question in the chat from Serena.
Right.
You can read it, and take it.
Thank you. Yeah, so Serena wrote, so we work on musculoskeletal image analysis. What would you recommend as an entry point to use the tools you create? Yeah, so I guess that depends on a few things. How do you have an established pipeline? Do you, how familiar is your team with, with the ecosystem already? We have Scikit image is a fairly good starting point when you want to do 2D types of analysis. We're working towards more n-dimensional, but I'm not quite sure in your problem whether you would need that. But we have fairly good tools for 2D analysis. And then if you need to move towards more real-time analysis, like handling video feeds and so on, then OpenCV still remains one of the best optimized library to do that. But maybe you can give me a little bit more information about your project, or if you prefer to continue the conversation afterwards, I'd be happy to have a chat.
I'll also add that, yes, it'd be great to have the conversation offline. One of the things that the challenge we had is as we were establishing this, it was the middle of the pandemic. And so there was a really difficult time having online events. And I think it also had a lot of early work was done in sort of getting the flywheel started. I think we're now in an area where we want to have more interaction with the community at Berkeley, but also locally. So I think we're going to be having, trying to organize more events where we bring people together, different types of summits. And we've done that across projects, but I think it'd be nice to have a set of local projects as well. I'm not sure, but it looked like you might be at Stanford. We have a lot of collaborations with Stanford and would love to have more. But yeah, please reach out to us.
Stéfan, maybe another question for you. One of the most amazing reservoirs of energy, creative energy, intellectual energy, time that a university has that's unique is its pool of undergraduates and also graduate students. So in general, the student population, that's a really special part of being, and it's kind of what makes a university, right? And but if we compare some of the retrospective that you made about the early days of Scientific Python, even at Berkeley, and today, one important thing has changed, right? Now we are teaching, I have the data on how many students take data 8. And years ago, I had said, I'm guessing when we reach steady state, this is going to be on the order of half of campus. And it is basically dead on half of campus. So I have the data from the enrollment of data 8. That data 8 is taken by 50% of the university. Data 100 is not as much, but still on the order, if I remember correctly, about 30%, give or take. That's an upper division course that's reasonably advanced data analysis with Python. And so we have now a population at the undergraduate level that on average, right? If you're going to throw a rock, you have a 50-50 chance of hitting someone who's used to using Python and who also has access to all of this incredible infrastructure of cloud-based data hubs that are deployed there for the entire campus to use. How do you imagine kind of harnessing that energy? That energy now is much better prepared, the ground layer has been built in that population, right? To be much better aligned than anything we could have remotely dreamed of 10 or 15 years ago. What do you imagine in terms of engaging with that community and that resource? Both ways, in ways that benefit your goals and in ways that benefit them as well.
Right. Yeah. It's such a fun topic to think about as well. And you know what a lot of people don't know is that the whole ecosystem was in large part built by students. Of course, things have changed a little bit now in the sense that the ecosystem is more mature. So it's harder in that sense to get involved. You know, when you work, I could, as a master student, work on NumPy no problem, because it was essentially so broken that anything you did to improve it was fantastic. Now, you know, that library is much more sophisticated. It's got a bunch of features. It's well tested and so forth, so much harder to walk in there. But there are still new libraries being formed. There's, you know, all the time people try new things in the ecosystem. So there are still ways to engage with that ecosystem. It's not trivial to engage with a massive amount of collaboration all of a sudden, because you have, you know, part of the way we develop our tools is we make sure that the code contributions are carefully reviewed. So as you bring more developers into the space, you also put a bigger burden on the reviewers that have to handle that load. So I think we have to think a little bit about, you know, what is the best way we can take that effort and do work, but then sort of polish that work up before it reaches the interface with the ecosystem. One effort that, like, we've done some experiments in BIDS along those lines around, trying to remember, it was around 2016 or 17, maybe for a few years I ran something I called the machine shop. And the machine shop was basically small teams of students that would come in and they would work on a specific data science challenge. And several of the tools we wrote for that actually went out and was used. I mean, we did some work for the Natural History Museum that they recently published, and we did work that ended up in, you know, in computational libraries that are being used today. That relied on someone on campus taking the role of mentorship, but the students very often more or less coordinated the work in their little teams. So I think with some lightweight organization around effort like that, we could really we could harness a lot of that potential. I think it's incredibly valuable to participate in an open source project. You learn so much in the process, and you hang out with some of the best developers, you know, in the world. So, you know, these are people who volunteer their time just because they care about a topic. So they're passionate, they know what they're doing. And that's how I learned most of what I know about software engineering today. So yeah, worth thinking about, worth getting the students involved if we can put the right infrastructure in place as to not overwhelm the existing community of maintainers. Alec?
Yeah, hi, Stefan. Thanks for a nice overview, especially the community. Maybe taking off from Fernando's comments about, I would call it maybe the local Berkeley market for your products, and sort of coming at the issue of trying to understand the various interests within and outside of the community. Do you have any notion, other than, of course, everyone's personal observations, about the demographics of course, your participants, your developers, and people directly involved in governance, but most specifically about the user community and the user communities, especially when you're addressing multi-domains that are quite distinct. I mean, genetic sequencing and cosmology come together, maybe just down at the matrix. What, you know, in a corporate setting, this would be a marketing department that would deal with their expertise and their funding as well.
Yeah.
So any thoughts about sort of taking what Fernando was saying about the Berkeley opportunity and casting the broader net and then seeing how that works down to the local situation?
Yeah, I'll say maybe first that we really welcome participation and very wide participation. There are many reasons, systemic and otherwise, why participation is not where we want it to be. But from our perspective, we benefit from greater diversity in the developer community. So we want to improve the onboarding processes. We want to improve how friendly the community is. We're always thinking about how to better integrate with the community. How our user community looks is not such an easy thing for us to measure because, as open source libraries, we don't typically collect telemetry and we don't have front ends on top of this library, although there are some thoughts floating around on how we could engage with Project Jupyter on getting permission on asking some of these questions that we want to know. The ecosystem very much developed by way of people scratching their itches. They would come in, they would volunteer a piece of work, and that work would be integrated, and that's how we got to know one another, and that's how we grew the project. So it's not been run as much as a traditional project as and working in an ecosystem where you become aware of a problem and try to address that problem.
Maybe there's some hope that an open source program office might be interested in that and could provide the various projects with at least help in understanding users and community better.
Yeah, for me, what's exciting about the project office is, as I mentioned in the talk, I think it's a point of connection, like BIT is too. It's a point where people come together and they can talk about a topic. It's right now, if you have questions about open source, if you want to engage in the process, or if you want to know about someone who's active in open source on campus, there's no place to go and have that discussion. So I hope we can, through the OSPO, broaden that space.
Maybe throw in DLab as well. So.
Yeah, absolutely. And just to add to that, I think as BIT is getting relaunched, both with the new faculty director and also with the new home coming up, I think there's a lot of excitement with the OSPO and other things about trying to figure out new spaces to meet and new collaborations to have. So I think possibly over the summer, the funding for the OSPO is not a lot, and I've got a lot of the projects, but I'm going to be starting to reach out and trying to figure out different labs and different groups to connect. D-Lab's an obvious one. We also would like to have a better integration with the library and all the other various groups on campus. And I know that Stanford has an OSPO that we'll be looking at, and one of the things they have is a contributor and maintainers roundtable. So we may be looking at events like that where we'll have forums where grad students and postdocs and researchers can come together and share lessons and tell each other about projects they're working on. And so if people have ideas for things like that, I'm all ears, and hopefully we'll be setting up a number of these events over the next year.
And Stefan, I know that I asked about things on campus because we are a campus entity, but I also know that we have a number of guests on Zoom who are not Berkeley guests. And so I'm wondering if any of them have questions for Stefan and Jarrod and for us, because as Stefan also pointed out, these projects kind of are a hinge between our campus community and expertise and a broad distributed community. So if folks have questions, please don't be shy and join. And we look forward to knowing where you're coming from and finding ways to connect with you. If you were interested in coming to this talk, it's because you have some interest in our work and we'd love to connect with you. So please, I want to encourage our non-Berkeley guests to kind of participate or ask questions if they have any. It's great to see some outsiders. And maybe
Yeah,
Stefan,
can I make one comment? Yeah, I see. I see.
Go ahead and connect with the outside community. Please go ahead.
I just see that Guy's on the call. Guy and I work together on with Josh Bloom on Sky Portal. I think that for me has been one of the most interesting projects. Scientific platforms developed at BIDS. So this is an astronomy platform that we developed together with Caltech and several other institutes. And it's a place where it's basically a platform that uses all these open source tools that we've built over the years and brings all these tools together in a single web platform where astronomers can come and talk about their work, share their results, and accelerate discovery. And I think that is such a beautiful example of how all this work is paid off over the years. You know, we've been working on this on these fundamental layers in the ecosystem, and now finally we have this thing together that culminates in a platform that allows hundreds of astronomers to accelerate their workflows. And
Stefan, you guys have factored out some generic components of that too. So it's something where there's already now, I think that's a lot of the work we do is we try to find the generic parts, and hopefully we'll be matching up with other people. So maybe you could point people to some of that.
Yeah, definitely. I mean, many of the web platform, and then a lot of the ideas explored there could be applied equally well to neuroscience or biology or what have you. I think I saw Matthew Fikert on the call as well. He was instrumental in getting Spec 4 launched. That's the project that deals with nightly wheels. Thanks very much for your work on that, Matt. All right. Well, thank you very much for this opportunity to speak to you all and to connect. I really appreciate it.